All right, folks, just a quick review on some graphing stuff here as we start to look at analyzing data. So just going to show you a real quick graph here and just kind of talk about some of the important elements and things to think about. So first of all, you can see my graph has a title up at the top here. It says, how often do people in Stony Plain eat fast food? That's the main topic of my graph, so I have a title there that shows that. And then I'll have to move down a little bit here. You can see that I have a title for both my x-axis and my y-axis. So you'll remember from our unit previous to this where we talked about coordinate grids and graphing, we have an x-axis, that's the one that goes across the bottom like this, and a y-axis or a vertical axis that you see here, and both of those have titles. So I don't always label X and Y here, but I always give them a title here. So this is the number of times per week that people eat fast food, and then this is the number of people, as in number of people that voted for that particular option. So you can see my data here. Okay, I've got my bar graph filled in here. And then the last thing I want to bring your attention to here is scale. So it's always incredibly important to think about what is the scale of my graph, and the scale is basically what is each block representing here, and what makes the most sense for the data that I collected here. So what I would have done to choose this is I would have looked at my information. Okay, maybe it was in a tally chart or something like that, and I would have looked to see, okay, what types of numbers am I looking at in terms of how many votes are things getting? And I would have thought to myself, okay, well, the highest thing that I have is 50, the lowest that I have is 10, so maybe it might make sense for me to go up by 5s because all of my numbers are in that range. Okay, so you can see here each block is 5, right? 10, 15, 20. Now the 15 and the 5 obviously are not labeled here, but we can see that every 2 blocks is a 10. Okay, so that tells us that in between, oh, it must be the 5, 25, 35, 45, and so on. So important things to think about when you are making any type of graph: scale, okay, and labeling all of your pieces of information. All right, folks, so continuing on here. We're also going to talk about line graphs today as well too, our plotted point graphs. So if you haven't already taken a look at your textbook page, this is the one that you're going to be looking at here. It's actually starting up here on page 259. I'm going to start down here though. So you're going to see in your work today 2 different types of graphs. One where you have a collection or a series of points here, which we call discrete data, where those points are not joined, and that's intentional. We'll talk about that in a second. And you're also going to see graphs that look like this, where we have what's called a continuous line graph here. So looking back at this one right here, so if we look at what this graph is about, it is about bike helmets being sold over some time, like April, May, June, July, August, September. So we have the number of helmets that are being sold, and then each month, okay, there's a value given there. Now, the reason that these lines or these dots are not connected with a line is because there are not numbers that are in between there. So they're another way to think of it is that you're not selling ever half of a helmet. You're selling like whole numbers of helmets. So we don't need to connect those points there because there's not information going in between. Now, to compare that or to contrast that, if we look at a graph like this one down here that shows someone's height, it's totally different ball game here. So if we, for example, talk about this girl here, Leah, between the ages of 2 and 3, right? We've got this point here that is just above 80 centimeters, and then we have this graph going up by 20, so then this one just below 100, so we'll say like 98-ish, right? So we've got between like 81 or 82, 98. Okay. Now the reason that this line would be connected here, that there would be a line, is because she doesn't just all of a sudden go from that height of 82 centimeters to 98 centimeters, right? It's a continuous growth over time. And so we put a line there to show that there is value in between those points. It doesn't just jump from one number to the next over time. So yeah, we call that continuous data. It's a line graph or a dotted line graph. And usually things like time, money, temperature, other measurements like length, mass, those things are things that would be continuous, right? So if you think about, for example, like a graph that shows temperature, I'll scroll back up here to the one at the beginning, right? This one that is showing the temperature in Nunavut, okay? There are values in between, okay, those temperatures, right? So for example, here, if we go from like, I'm guessing this is May, yeah, so we go from like May to June, okay, you can see that there's a temperature here of 4 degrees Celsius and 24 degrees Celsius. It doesn't just instantly jump between May and June, right? We have that temperature changing over that period of time. So that's why you would have, that's why you would have a line connecting those points there to show the values that are in between. So that's what you will need to know while you are working on your questions for today. One other thing that I wanted to bring your attention to was when we talk about like making a conclusion about a graph or taking information from a graph. So if I look at this graph right here, going back to the graph of Leah's height, okay, and I want to make a conclusion about this graph, or I want to say something about this graph, I look at the data and I basically interpret it as to what is it telling me. So if I look, okay, when does she stop growing could be one of my interpretations here. So basically, Leah stops growing at about 14 years old or has very little growth after that, right? So a conclusion could be, I could say, Leah does not grow very much between ages 18 and 20, or Leah stops growing at age 14. Okay, or I could say something about when she grows the most. I could say Leah grew the most between ages 2 and 3, or Leah Leah grew the most between ages 2 and 6, right? That's when it seems like she has the most kind of consistent jumping or most consistent growth happening there. So that would be conclusions that we can say about that. If I wanted to talk another example, maybe about this temperature graph here, I could say conclusion from this graph might be that December has the coldest average temperatures, or July has the warmest average temperature. So it's basically just what's information that I can take from this graph. What's a specific thing that it is telling me?